Good morning, good afternoon, and good evening to wherever you are in the world. My name is Andrew Glaser, and today I would like to teach you how to use the following graph to write an equation for a rational function. All right. So turns out that there's going to be two important things we got to focus on: the intercepts and the asymptotes. Let's focus on the intercepts. So there's two types of intercepts. There's going to be x-intercepts and y-intercepts. Remember, these intercepts are just where the function crosses the x-axis and the y-axis respectively. So where does the function cross the x-axis? So remember, the x-axis is the horizontal axis here, and it appears that it crosses it right at this point. So I'm going to estimate that. It doesn't look like, 3 would be like here, right? This one's a little tough. Doesn't look like 3 to me. It looks like a little less than 3. So if you say it's 3, I wouldn't necessarily totally disagree. It doesn't appear to be exactly 3. And if 3 were here, then 2.5, it looks like maybe 2 3/4. All right. But I don't know if we should get that particular. It might just be a problem with the picture, quite honestly. So why don't we just approximate it? Let's just say it's 3. Screw it, right? Let's take the easy way. So the x-intercept, okay? So across the x-axis at 3, I'm going to list the coordinates for it. All right, so 3, 0, because the y value is 0 there. And there's only one x-intercept. And if it's a function, there should only be one y-intercept as well. So across the y-axis, it looks pretty apparent to me that should be a -2, right? So 0, -2, those are the coordinates for that y-intercept, all right? Then we're going to deal with the asymptotes. So you got two types. You got vertical asymptotes, all right, and horizontal asymptotes. Now let's focus on the vertical asymptotes. That's the purpose of these red dashed lines here. Those are the vertical asymptotes. So it appears to me that this vertical asymptote here has a equation of y is equal to -3, right? That's the equation of that line. All vertical lines have y equaling some constant. Same thing here. That's going to be y is equal to 4. So those are my two vertical asymptotes. So I'm going to write x is equal to -3, and also x is equal to 4. As far as horizontal asymptotes, this thing kind of does approach, all right, the x-axis here. Right? It does approach that x-axis. So we basically have a horizontal asymptote all the way out on the tail at y is equal to 0. But anytime you have an asymptote equaling 0, you can just kind of disregard it. All right? Here, especially with the horizontal. So that's basically all I need. All right? Now after this, I can start to begin to write the rational function. So remember, a rational function has some function on the top, meaning some polynomial, and some polynomial function on the bottom. Let's first focus on the bottom. Now, that's where the vertical asymptotes come into play. These vertical asymptotes represent x values. These are x values that you cannot plug into this formula because it'll give an undefined result. Now, the only thing considering basic rational functions that's going to cause something wacky to happen is if the denominator is 0. So that's what I'm focused on, right? I'm focused on what factors here, okay? What can I write in here? What two expressions can I write such that if I were to plug in -3 for x, it causes it to go to 0. Well, what happens if I wrote x plus 3? And let me give myself a little bit more space. What happens if I wrote x plus 3? Well, if I wrote x plus 3, and we saw from the graph that x cannot be -3, well, if I plug in -3 here, I get a result of 0. And if this is 0, right, if it's times some other factor, who cares what this is? It doesn't really matter because it's still going to be 0 in total in the denominator, right? Let me just clean this up a little bit. I just want to make that line a little straighter and extend it. Okay, so same thing then with the other vertical asymptote. Just simply write x minus now 4. So the trick is basically take the signs, flip them, and then just write them as factors. Easy enough in the denominator for the vertical asymptotes. Now, turns out the x-intercept, okay? The x-intercept now, we're going to treat it very similarly to how we did the vertical asymptote because the function's value now, it does obtain a value, but it obtains a 0 value. So in other words, the function has to be 0. Now the only way that this expression on the right-hand side goes to 0 is if 0 is in the numerator now. So basically, the x-intercept will tell you the factor of the numerator. So you're going to write x minus 3 because again, if x is +3, when you plug that in, 3 minus 3 is going to be 0. So the trick is, again, just flip that sign, okay? And last but not least, we're going to take care of our now y-intercept. So to take care of the y-intercept, what we're going to do is we're going to add a constant in front, okay? There's going to be some constant that we're going to have to multiply our fraction by. in order to get a y-intercept of -2. Because keep in mind, what this is basically telling you is it's saying, never lose sight of this, is that when x is 0, the function's value or the y value or the f of x value is -2. So if I have this expression already, I can start to plug in this f of x is going to be -2. And then I can start to plug in zeros here for all of my x's. Now, obviously, you have to take care of this after you have some expressions there. You cannot do this at the start. So always save the y-intercept for last. So it's going to be 0 plus 3, and then it's going to be 0 minus 4. Now, when I do the math here, we're going to get -2. Don't worry about the constant. I didn't forget about it yet, but I'm just going to show you. We're going to get -3 on the top, and then it's going to be +3 times a -4, which is going to be -12. Now, this obviously is going to become positive because it's a double negative. Now, tell me, does 3 over 12 equal -2? Obviously not, right? And that's the point. That's the point. Somehow we know that has to be true because that's what the graph tells us. But if I don't have a constant in there, there's no way I can make that work, okay? So I'm going to put in a constant. I need to find the constant. I need to figure out a value that will make this true, okay? So that's why the constant's there. Then to solve this, just simply multiply the right-hand side by that reciprocal, right? That cancels. And then whatever you do to the right, you got to do it to the left. So multiply the left-hand side by the same reciprocal. Now keep in mind that this is really 12 over 3 is really 4. And this is not -2, it's really 4 times -2. So what that would come out to be is that would be -8, right? -8. And that's your constant, or your coefficient. So go back to the original, just erase your little c there. All right? And then -8. Okay? Well, little c. Reminds me of my friend I used to work out with. Carmine. Hey, Tiny Man, if you're listening, this one's for you. So, sorry. He's definitely not listening. But anyway, if your name's Carmine, don't take offense to that. It's just an inside joke between him and me. He and I? He and I. Him and me. I don't know. You ever like flummoxed with all that he and him and I and me before I and I after E? And I feel you. I know. That's why we're doing math. Okay. So this is basically the answer. All right. That's the answer. Now, you can factor FOIL the denominator, all right, to kind of clean this up a little bit. So all you're going to do is just do x times x, then simply take these, add them together, which would be a -1, and then slap on an x, so it's -x. And then just multiply the +3 and the 4, which is -12, right? That should hopefully be good by now. So that's going to be x squared minus x minus then 12. So this is basically the function. All right, you could have left it in the other term, the other way, but this is probably a little bit better. You can always check yourself, then go to your calculator, right? So write -8 times now. I'm going to do a parenthesis. I'm going to plug in the numerator. So x minus 3, you got to have your parentheses. If you don't plug in your parentheses like this, it's going to come out wrong. So please be careful when you plug in the calculator. All right. And that's why I have it here, because I want to teach you how to use it properly, because it's a very powerful tool. So then hit graph. And look, that function up there on the left, or that graph, looks pretty, very, basically similar, identical, right? It looks a little kind of wider, fatter, but that's just the way that the picture looks. All right. Also, that's because they're counting, if you notice, the x-axis here is by 2. 2, 4, 6, 8, every kind of line. And the y is going to be 1, 2, 3. So this axis I have up here, every x value represents 1 instead of 2. So that's why it looks a little, like, wider. Anyway, it's the same thing. All right? So, guys, thanks so very much for tuning in. I really do appreciate it. Check out our channel because we've got thousands of videos out there. Not only in math, but physics, chemistry as well. We focus on problems because guess what you're going to see on your test? Problems. You got to know how to approach them and the logic behind them. All right? And that's what we really try to stress. We don't just want to teach you a method, although we want to give you a method, but we want to teach you why it's working. Why do the vertical asymptotes go in the denominator, let's say? Why are we creating factors for them? Right? So on and so forth. All right. Enough of that. Take care.